Welcome to my channel, Statistics for Applied Linguistics. I'm Dr. Marnie Manegra, and today we are looking at the participants or the sample of a study. Keeping in mind, sample and participants are synonyms. Okay, so the participants or the samples, when we describe the participants, we're describing the background variables. And not all of the background variables are relevant in your study. So as an example, if all of your participants are born in Spain and they are bilingual with Catalan Castellano, you do not need to describe their ethnicities or religions on an EFL task. Gathering the background variables is done typically through the pre-questionnaire, and for our class, we're going to be using Microsoft Forms. Do not gather personal data on this form. So you're not going to collect ID numbers, exact birth dates, full names, any of that personal data. The personal information should only be gathered on the participant consent forms, and that data needs to be stored separately from the study data. Personal information should never be analyzed. So when we look at our participants, we have an internal validity threat. Now, the first and the third one on this list, we don't need to really worry about at a master's level course because you don't have enough time for your study to worry about maturation. So this would be a natural change in the participants over an extended period of time. Selection, though, this would be any systematic differences between the groups. So as an example, if you are comparing two different classes of students, and one is at a higher grade level than the other class, then we've got a systematic difference between the two groups. One group is older and they've been in the school system a little bit longer than the others. Now, selection by maturation would be the groups systematically differ in their maturation. Again, at the master's level, we don't really need to worry about this one. So there are also external validity threats. The first one is reactivity. This is when the participants are aware that they're in a study, and so they're behaving a little bit differently. They're not acting natural. The other one is a selection threat. So the hypothesized relation only holds true for a subset of people, and a selection threat can be minimized with random sampling. So when we look at random sampling, there's various ways to do random sampling, such as taking the third number on each list, or just randomly dividing into groups. But we're going to look at non-probability sampling. Convenient sampling is one that's most often used in studies because professors tend to use their students. At the master's level, a lot of the students will use their students from their practicum. So this is the most convenient group that is available to you. And then we have snowball sampling. Snowball sampling is where you start with a group of participants and you ask them to give you contacts for new participants. And then with the new participants, you ask for contacts of other new participants. So that is called snowball sampling. Purposive sampling, the elements are chosen based on the judgment of the researcher, and they're judged to be typical for the population by experts. So this is if you're looking for something very specific. Quota sampling. Participants are selected according to specific characteristics. So I need to just look at those who identify as female for this study, or a particular age group. I'm studying preschoolers. There are other threats that we can have. One is artificiality. The participants are aware that they're being observed. The experimental expectancy. This is an unconscious change in the researcher's behavior that influences the results. So if the researcher knows which group the participants are assigned to, they might unconsciously treat the two groups differently. And then we have demand characteristics. This is a change in the participant's behavior due to the expectations from the study. So if the participants are aware of what the study is about, they might try to meet that expectation. So how can we avoid these threats from the experimenter or the participants? The first is a blind design. Any information about the study can be withheld from the participants until after the study is complete, and then you would give them the information sheet. Now, if you have more than one researcher, you could do a double-blind design where the person collecting the data has no idea which group the participants are in. And so that information is withheld from the experimenter. And additionally, the participants do not have the information on the study until it's complete. The third way to do this is a cover story. The participants are given a cover story for what the experiment is about, so they don't know what is actually being tested. Now, when we look at the sample size, so once you've selected your sample, and if possible, a randomized sample is the best, but once you've selected your sample, the sample size matters. So the goal of sampling is to get the best representation of the population, and as the sample size increases, the margin of error decreases. So the magic number in linguistics is 30 or higher. So if you have more than 30 participants per group, that's going to increase the reliability and save you from doing a more complicated analysis. And so I don't have the source of this particular meme that I had found on the internet. If anyone knows the source of it or the original author, please write it in the description below. But this is why I have trust issues. If you have a small sample, you can get the same R value. So this is the same statistic number, but we can see that the data is behaving very differently. So a positive correlation would be seen in the first one, but the fourth image does not show a positive correlation. But with a small sample, it's giving the same number. If we had a sample of hundreds or thousands of participants, we're not going to run into this issue. So as the sample size increases, the reliability of the results is also going to increase. So really, the data, if you have a small sample, should be normally distributed. And so if we see a normal distribution, that is that bell curve at the bottom. A uniform distribution is just flat across the top, as we can see in the top image. But a bell curve is the normal distribution. And so when we hear that teachers are grading on a curve, there are less students with the highest score and less students with the lowest score, and most of the students are going to be graded close to the mean. A skewed data looks like this. So left skewed would be like a ceiling effect, and right skewed would be a floor effect. So if a teacher is grading a test and all of the students score 90% or higher, then you've got left skewed data. Now, if all of the students fail with 30% or lower, you've got right skewed data. That is a floor effect. That's an indicator of a poor test. It's not actually testing the skills of the class. A normal class would have a regular bell curve. So for our population, if we have a small sample size, we need to see that regular distribution, that regular bell curve. So what you will do if you have a small sample size, first thing we're going to look at in the first box to the left, are there more than 30 participants per group? If the answer is yes, you can move to a parametric test. And I will show you the difference between parametric and non-parametric tests on the next page. If you have less than 30 students per group, which is somewhat normal for the master students, depending on the classes and the class sizes that you're going to be working with. So if you do not have more than 30 participants per group, do you then have more than 10 participants per group? If the answer is no, Then you're going to use a non-parametric test, and we'll have a look at some of the non-parametric tests on the next page as well. Or you can use descriptive statistics. It's very rare that you'll have less than 10 participants, but in cases that you're doing a study with preschoolers, it's really hard to get preschoolers to participate through a whole study. Or if you're looking at samples of people that are differently abled, then you're going to have a small sample size. So in that case, if it's less than 10, you're going with non-parametric tests or descriptive statistics. However, if you have more than 10 participants and less than 30, you're going to use a Shapiro-Wilk test. The Shapiro-Wilk test will tell you if your sample is normally distributed, if you have that bell curve. So if the sample is normally distributed, you're going to use a parametric test. If the sample is not normally distributed, you're going to use a non-parametric test. And I will have a subsequent video that will show how to do the Shapiro-Wilk test. So this is how you decide which type of test you're using, parametric or non-parametric. So the parametric tests, this is where you can use Pearson's correlations, t-tests, z-tests, and NOVAs. For non-parametric tests, you're looking at Spearman's correlation, Kendall's tau, chi-squares, and Mann-Whit mu. Now, this is going to be for data that is skewed. It can be ordinal data, and it can be nominal data. So that's where you use a non-parametric test. But for populations that are using scale data with more than 30 participants, you're going to use parametric. Okay, so this takes us to the end of this lesson. Thank you so much for joining, and I look forward to seeing you in the next video.